Hello, my name is Brighton Cox, and this is my Physics 2211 Lab 4 presentation. Intro. The purpose of this lab was to observe the oscillating motion of a mass attached to a spring and observe its changes in energy. Some fundamental physics principles that are present throughout this lab are Newton's second law, which is the momentum principle, and the energy principle. As a brief preview, we found out that the change in total energy of the system oscillates around zero. It is also noteworthy that my model ended up being different than my experimental data. Physics principles. So as you can see to the right, top right, F net equals the change in impulse over change in time. That's a formula we've been using all semester. Same thing with the change in position formula, the velocity update formula, the force of gravity formula, and the change and potential energy formula. And then below that, we can see the kinetic energy formula, the change in kinetic energy formula, the force spring formula, and the change in potential spring energy formula. Systems and surroundings. System. In this experiment, the system includes the mass, the spring, and the earth. The surroundings. In this experiment, there are no surroundings. And because of our system and the fact that there are no surroundings, W of the surroundings, which is the work of the surroundings, is equal to 0. And this is our video. It can play. It was the video we were all given, and then I used it through Tracker to get our data, which we're going to go into right now. So initial conditions. So we were given that the mass is equal to 0.402 kilograms, and the initial position, which I found through Tracker, was negative 0.079, negative 0.654, and then 0 meters. And then the initial velocity, because the object was at rest, it had an initial velocity of 0. And then the change in time was 0.095 seconds, which is how long the video went on for. And then to the right of it, you can see our code, which shows these exact initial conditions. And then you can see some more of our code. The G, which the constant of force is 9.8. The spring constant 6.87, which we found. L naught 0.127, which we also found. And then you can see some of the formulas that we found. Kinetic energy, gravitational potential energy, spring potential energy, and total energy. You can see by the hashtags, it kind of just describes exactly what we're finding. Some more of that goes here into our code. And then basically what we're trying to calculate was calculate the energy changes, which is shown by lines 37 through 44. And then finally our computational model, which was GlowScript. You can see that delta E oscillates around 0, which means basically it rises right above 0 and then goes down right below 0. So it ends up changing out to be around 0. Predicted and observed data. So as you can see, to the left is our predicted data and to the right is our observed data. And they are very different. They're pretty different, which means we probably had a couple errors in our data through our testing, but it just shows that they're relatively pretty different. And what does it mean? So the what does it mean questions for our model system: is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. So I decided that since change in energy is equal to work, no work equals no change in energy. So the energy principle is satisfied. So it's basically just one of the formulas we're referring to, and since the surrounding work equals 0, change in energy also equals 0. So using the data we obtained in Tracker, make two separate estimates of oscillation periods. First, by estimating the period of oscillation from the x position data, and second by estimating the period of oscillation from the y position data. Compare the two estimates and discuss. So our estimate for the x position was 1.53 seconds, and for the y position was 1.39 seconds. And we found this just by playing around a little bit with a Tracker and seeing what would work and what would help our estimates work. And then possible errors. Some possible areas for human error were throughout the GlowScript code and the Tracker process. Obviously, we're not perfect, and we try to make Tracker as accurate as possible, but there's definitely area for human error. And then GlowScript code, we're using very rough estimates, so we try to get as precise data as possible, but it's not always possible. And then, yeah, that's it for my presentation. Thank you for watching.